Hello, we are going to learn solving a first order differential equation by using technique separation of variables. Before this, we must learn what is a differential equation. Now, I would describe a definition of differential equation. Simply, its a definition is an equation in which involving functions and their derivatives. For example, simply a differential equation, we it described from a word differential means a derivative, equation means it is in the form of equation. So now come on, it's a definition. It's said an equation in which involving function and their derivatives. So this is the basic example of a second order differential equation. Order shows the highest derivative involves in a differential equation. We can see that in this also involves a function, their derivatives. Number second example, for example, dy by dx plus x is equal to y. It's also a differential equation. A number third example, dou x square plus dou square z over dou t square. So this is the also differential equation. Then we said that there are two categories of a differential equation. Number one is ordinary differential equation. Number second is the partial differential equation. There is some difference in ordinary differential equation have only involving one independent variable. We can see in example number 1 and second there is only one independent variable, and we can in a partial differential equation involves two independent variables. 3 is our partial differential equation, because we can see x and t are independent and y it's a dependent. This is this is dependent and x is independent. Okay, but our main agenda is solving a first order differential equation, and we have must know what is the order. Order shows the highest derivative involves, so we only focus on a first order. This is the second order differential equation and this is the first order differential equation. Now come the technique of separation of variables. So in this technique, we solve a first order differential equation by separate the variables. For example, how to separate the variables. So for example, if we have a first order differential equation like this, so what we have to do, we take x in this function, we separate the x variables with dx and y variables with dy. For example, dy by dx equals to x upon y. Now it's a procedure is a solution. Step number first. we separate the variables. We separate the variables. Means a dy by dx equals to x upon y. Y should come in with a dy and x in dx. This is a separation of variables. Now step number 2, taking integration on both sides. Taking integration on both sides. So it becomes, now come to the next slide. So it becomes integration of y dy equals to x dx. Now we know that the integration of y with respect to dy, it's a become a nothing in power is a 1. It's also power 1, as we know that x something variable on n with respect to x, so we add in 1 in power, also that in denominator. This is the our basic integration rule. So it becomes a y square upon 2 equals to x square upon 2 plus arbitrary constant. We add must this arbitrary constant. So also this is the our solution, and we also simplify it morely, like here it becomes x square plus 2c. This is the also our solution. Thank you very much.